Assalamu alaikum. Our project title is Traffic Profiling and Intelligence Light for Smart City. My name is Raja Akash Anjum, and these are my group members Muhammad Sohail and Muhammad Bilal. With the growing world, we have to face two main problems. One is traffic congestion and another is energy crisis. As number of vehicles on roads are increasing with the passage of time, which creates many problems like road accident, traffic congestion, and air pollution, etc. In our project, we are trying to provide solution for these two main problems. In traffic profiling part, we are doing three main parts: vehicle classification, vehicle counting, and data analysis and modeling. In vehicle classification part, we are classifying vehicles on the basis of their shape. We are using camera integrated with single board computer. Like in our case, we are using NVIDIA Jetson Nano. There are many object detection techniques, like some of them are RCNN, RetinaNet, and Geolo, but these are memory hungry techniques. So we are using SSD MobileNet V2 that is specifically designed for mobile and embedded devices, and it can run on low computational power. Second thing that we are doing is vehicle counting. For vehicle counting, the software continuously counts the number of vehicles that pass through the surveillance camera. And the software classifies the vehicles and counts the number of vehicles. For example, software informs us how many bikes, cars, trucks have passed through the surveillance point. After it, the data that we collect from using surveillance camera, we send it to the NVIDIA Jetson, and using ThinkSpeak platform, we are sending this data to cloud for data analysis and modeling, where everyone can easily access this data. And our fourth part is we are converting normal street lights into intelligent smart street light. The rationale behind this task is that conventional street lights work on full intensity. Even if the road is empty, and due to that, there is lot of energy wasted for nothing. So we have introduced smart LED street light. By default, when there is no object detected, our LED light have 20% intensity, and when object is detected, the intensity will increase to 80%. And after the exit of the moving object from monitorized zone, the LED intensity will be reduced to its default intensity. Our main challenge is to implement this whole bulky project to some small embedded device so that it can easily be placed anywhere, and it should be cheap. We also optimize the weightage of our model using TensorRT. Now we are able to use four parallel cameras with our small Jetson Nano board. We have successfully completed our all tasks. Now Muhammad Bilal will further continue from here.
So another major part of our project is to design a smart street light with energy saving function because urban areas in entire world are dealing with energy consumption and carbon emission, a known contributor to climate change. Due to indicate dimming control and low efficiency, current street lighting is wasteful in terms of energy spending and carbon emission. For example, Howard is a large town in London where street lighting consumes 65,51,500 kilowatt of electricity per year, which leads to emission of around 3,900 tons of carbon per year. As you can see in this prototype, the microcontroller gather and send the information from sensor to the cloud, as well as control the intensity of street light. The web application access this information and analyze the data and predicting the outcomes. So the hardware is divided into three parts: power circuit, control circuit, and LED circuit. Here is the circuit that used to control the intensity of street light. Let me explain the circuit. As you can see, I have selected IR2104. IR2104 is a hub bridge driver that can deliver more current to the load. These capacitors are used to reduce the noise. I have selected 100 volt rated capacitor because 100 volt is equal to the MOSFET VDS tolerable voltage. This picture shows the desired PCB layout that can be designed in Proteus. I just used semi-homemade PCB to able to quickly assemble the board and test the circuit. As you can see, the top view of assembled PCB as well as the bottom view of PCB. Here is the demo video in which attached assembled PCB between AC supply and street light. To turn on the circuit, you can see the intensity of street light is successfully controlling by the PWM signal. Now our light is illuminated with 20%, 50% and 90%. That's all from my side. Now further Suhail will proceed.
Let's come toward the progress of our traffic profiling part of FIP. This part of FIP is further divided into the two parts. One is intelligent video analysis and second is data analysis and modeling. In IVA part, we have 5 tasks that are detection, classification, localization, tracking, and counting. Now we have separate algorithm for detection, classification, localization. And for this, we are using SSD mobile net that is specially designed for the edge computing. Now we have embed the tracking and counting algorithm to one algorithm and we call this algorithm as IVA algorithm. The center part is data analysis and modeling. In this part we have 3 subtasks. First is to send data to the cloud, to analyze and visualize data on the cloud and to act on that data. Now let's discuss the architecture of our traffic profiling part. First, we have cameras at the road connected to the NVIDIA Jetson Nano and Jetson Nano will encode the videos using H.264. Then we apply the image processing technique to apply different annotations on the frame. Then we apply deep neural networks on the frame. We are using SSD mobile net to detect the object. Then we apply tracking algorithm on the frame. We are using central tracking algorithm. In this, first we have to compute the centroid of the detected object. Then we apply correlation filter on the centroid to track it. The next task is to count the vehicles. We assign the IDs to the object or vehicles and count them. Then we display the frame and counting variables on the screen. Now let's see the demo of intelligent video analysis part. Here we are feeding the video to our IVA algorithm and our algorithm apply detection, tracking and counting on the frame. Now you can see the counted variables on the upper left corner. Now our next task is to send these counted variables to the cloud for data analysis and modeling. For that we selected the ThingSpeak cloud. We have written the separate Python code that upload the data to the cloud. Now let's see the demo of how the data is sending from NVIDIA Jetson Nano to the cloud. These are the counted variables and these are updating and uploading on the cloud in the real time. Now the next part is analysis and visualization of data on the cloud. Here you can see the data is changing on the real time and this is the bar graph, this is the gauge and this is the numeric data display and here we have the map of the channel. Now let's have a visit to our cloud. Here we have a channel ID, here we have a bar graph. Whenever we run the Python code of IVA, this data will be updated on the real time. Here we have a histogram of all the data coming to the channel. Here we have a heat map. The best thing about this cloud is that you can write any MATLAB code and run this on the cloud in the real time. Here we have a code of custom heat map and here we have the output of this code. You can download the CSV file of all the data that is coming into the cloud. Now this is the CSV file of all the data that is coming into the cloud.
We have implemented the threading based parallelism. With the help of this parallelism, we can run multiple video stream on a small Jetson Nano board. As we have a 4 USB camera port and 2 CSI cameras port on the Jetson Nano. Now we are able to connect 6 cameras and apply intelligent video analysis on all the videos in parallel. Basically, in this parallelism, each video stream is running on the different core on the GPU. This is a huge achievement for us. With the help of this, we can cover 6 different locations by using a just $99 embedded device. Now, after the completion of our FIP, our supervisor suggested us to design a website for this project so that the user can see the situation of road in the real time. We have designed a very simple and lightweight web page. We have designed this web page in such a way that on a button click it calls a different function of our Python code. We have designed this by using simple HTML, CSS and JavaScript. Suppose you have cameras connected at the different locations in the city, and if you click the live button This will show you the real-time situation of the road. Now let's visit our website. Here we have a list of roads. Now by clicking this button you can access the live feed from the video. We are using the Flask application for the integration of user interface and the backend. Now you can see how accurate our counting, tracking and bounded boxes are. We have also tested this on a real scenario. We tested our project on Islamabad highway and the results were amazing. If you want to watch the traffic situation of all the roads, then we are making it possible for you on a single click. Now that's all from my side. Thank you.